Hello everyone, this presentation is about dealing with a classic transportation problem. Namely, we are trying to minimize the distance in certain given conditions. That would be the objective. And the story is the following. The table representing the distances between 3 warehouses and 12 delivery points. Now, the conditions would be each warehouse has to deliver to 4 delivery points, and each delivery point should receive merchandise only once. Now, evidently, this is a problem that it is very simple, can be easily solved by other tools, but the point is not how many tools can solve this, but rather to see how q-dss is dealing with this sort of mathematical model of transportation problem. And since q-dss does not have a dedicated UI or API as data entry, then I will use the classical CSV file in order to understand the model, for q-dss to understand the model and to solve it. And I will add some extra information here. I will actually stop it after each step in order to explain what each step means. So step 1, the logical one, loading the data from the CSV file. Second is to transform the mathematical model into a Boolean satisfiability formula and port it to a different file. Sorry, with the CNF extension conjunctive normal form extension, and the file contains 36 variables and over 2400 clauses. Now, next step would be to understand the objective, which is to minimize the distance. Third step is to solve the model using that set formula. And obviously, number 5 is to map the model to the original data while finding the optimum. And there are over 34,000 possible solutions in this formula. And it looks like the optimization for the distance is this one. The optimal distance would be this one. And we could actually easily map the result to the given mathematical model. So warehouse 1 sends to DP2, and let me make it yellow as well as all the others. Then to DP6, and then to wait, let me copy this format. Then DP6, and then DP11 and DP12. And then warehouse 2 is sending to DP1, 3, 5, and 9. 5 and 9. And obviously the last one should cover for all the rest. So that's DP4, DP7, 8, and 10. And now let's see whether our algorithm did the right job with considering this as a minimum. And let's add all of those together. It looks like is the same sum. So as I said, this model, you could take a snapshot of the screen and try to solve it manually. It's going to take you maybe a little bit of time, but it's solvable, and perhaps you can find a better optimum, although I tend to doubt about it. And as I said, this is a very simple classical example of an optimization problem related to transportation. And that concludes this recording. And until next time, stay safe and talk to you later. Bye-bye.